Looks like everyone was on the right track here. So our goal is to factor out the biggest thing we can, undistribute the biggest thing we can. So what are we, let's do it this way. Okay, greatest common factor. We always want to look at this. We can break it into a number part and a variable part. Biggest number we could undistribute would be an 8. The biggest power of x we could undistribute would be an x squared. And then to see what's left behind, we could just divide each term by our GCF. Or you can do it in your head. So if we do this, 8x to the 4th divided by 8x squared would give me x squared. Negative 24x cubed divided by 8x squared gives me, good, negative 3x. And then 40x squared divided by 8x squared is 5. Okay, good. And then we can't go any further than this because there are no magic numbers that work. We can't find numbers that multiply to positive 5 and add to negative 3. So we're stuck with that trinomial. That's as far as we can go. Okay? All right, give me thumbs. We good on that? All right, next one. Okay, try that. Should be some in that over here in this thing. Okay, they're all gone? Okay. I'll try to find some. That's got to go away. If I can't find them, you might have to just use paper. Let me look and see if I can scare one up here, though. Yes. That's good. Not quite. Good. Nope, nope, nope. But there's no minus sign in the middle. Good. 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 Okay. Let's talk about this one. Man, I have no more markers. I'm sorry. Gosh, okay, I'll get some more before we do this again. Okay, here we go. So on this one, no, close. Okay, so our goal here is, right, now let's, focus up here, please, eyes up here. So the idea is we've got an x squared term minus something. Okay, this is one that could fit our difference of squares pattern. So let's remind ourselves about that. A squared minus b squared. And a just means the first thing that's being squared, and b just represents the second thing that's being squared, right? What's the pattern? What does that factor into? Well, I'm just the pattern for now. Don't worry about the problem. Okay, a plus b times a minus b. And usually, it doesn't make any difference the order. Usually we write the minus first. That's how we've done it. So it factors like that, right? So our goal is, can we get our binomial to look like something squared minus something squared so we can use this pattern? The second something's pretty easy. 64 is what squared? 8. Okay, what about the first something? 5x. There we go. So we're just going to follow our pattern then, right? What's our a? Our a is being replaced by a 5x, right? So we end up with 5x minus 8 times 5x plus 8. And there's our answer. Okay? Thumbs? We good? Okay? Next. Try that. Factor completely. Okay, so real quick, when you see factor completely, what's that mean? That means we want to break it apart into the smallest factors possible, as many small factors as possible. And when I'm all done, I should be able to multiply that string of factors together and get back where I started from. So what do we always try to do first when we're factoring? Greatest common factor. We always want to undistribute first, right? Greatest common factor. So what I heard somebody say it. What could I undistribute? 4. Okay. What am I left with if I do that? V squared minus 64. Very good. So we done? No, heck no. We can go further. Right now, here I've got a binomial. See if I can break that apart. So 64 is what squared?
8.
Ah, okay. So that looks like a difference of squares, right? Okay, so then I've got that 4. You know, once I get a greatest common factor, it's just stuck out front the whole time, right? So that's out front. What is v squared minus 8 squared going to factor into? Good. That's it. That's as far as I can go. Okay, you need that 4 out front too, though, right? If that wasn't there when I FOILed this out, I wouldn't get a 4v squared, right? Okay, give me thumbs. How we doing? Okay, okay, okay. Yes?
Couldn't you, do you have to factor out the greatest common factor because you do it like this?
Yeah, no, okay, so the question is, do I have to factor out the greatest common factor? Because if I didn't, I could write that as the quantity 2v squared minus 16 squared, right? And so I'd end up with something like this. 2v minus 16 times 2v plus 16. But when I'm all done, I shouldn't be able to factor anything else out. Now look, I could undistribute a 2 from this one, couldn't I? And a 2 from that one. Yeah, so I can't stop there because there's still stuff I could undistribute. It's way easier, though, you always want to undistribute first because it makes the rest of the job a lot easier. Yes, ma'am?
Can you scroll up so?
Yeah.
So, I know how to do this, but I think I just blanked because I'm confused as to why. Oh, wait. Just kidding. Never mind.
You got it?
Yeah.
Okay.
I just missed something.
Okay. Okay, any other questions? Anything else? Question? Okay, another one. Okay, this is an easy one, right? This is an easy one. This is a simple trinomial because a is equal to 1. There's nothing I can undistribute in this case, correct? What do the numbers have to multiply to? Negative 45. They have to add to? Negative 12. And that's all I've got to do, right? If I know that I can split this thing apart here. And the template's going to look like that. I just need to know what magic numbers go with the x's. What are they? Okay, I got to get the signs right. So what are they? Negative 15 and positive 3. Good. Okay, so that's all they want from that one. What about what?
I don't know, I know how to solve all these, but I don't know which one to use in a certain time.
Okay, well, so, I mean, it's...
This looks like the exact same problem as last time, but we didn't do this last time.
Right. Okay, so you mean like the same problem as that one, right? Is that one, right? Well, it is. It is. You're factoring, but the difference is I've only got, this isn't a trinomial. I've only got two things here, right?
So if there's 3, then you do the other one.
Yeah, if there's 3, you do a trinomial. We always want to factor out the GCF first, every time. This time,
3 in the first one.
what's that?
There was 3 in the first one.
Okay. Okay, let's go back. That one. Yeah, there was. You're right. There's 3 in this one, and we're supposed to factor. All they told you to do was factor out the greatest common factor, which we did. We undistributed an 8x squared, and this is what we got. Okay. How come we couldn't go any further? Because there are no magic numbers. So that one, we can only factor a trinomial if we can find magic numbers, right? So I'll give you an example. So like, do you see why these are different though? Okay, these are binomials. Okay, but you're interested in something like that, okay? So what was the next one we did? We haven't done one yet. Okay, so this is the one we were just working on. Okay, I'm going to give you a different one. Factor this. Okay, what would the magic numbers have to multiply to? And add to? Okay, are those? Yeah, right. Hey, shh. Get too much talking. So there are no magic numbers, right? So I can't factor that. That's factored. That's the answer. Because there are no magic numbers. Yes, exactly. Okay? Does that make sense? Okay? Does that help? So you only factor when you can. Okay, now what about this guy here? Okay, so this is a trinomial also. This one's tougher though. How come? No. But what's...
It's where you,
You're doing the motion, slip and slide. Yeah. Okay, we'll try to factor out a GCF. Yeah.
I thought that was when like you had hair back in the day.
Yeah, well, yeah, it's been a while. Jeez. Okay, so we want to try to undistribute, but we can't do it, can we? Right? Nothing to undistribute. So this time it's slip and slide because we're stuck with a number in front of the x squared. A is not equal to 1. That makes it tougher. Okay, so slip and slide. Yeah, what do we do? What's the first step in slip and slide? Okay, good. We're going to slip it to the end and multiply. Good. So we're going to slip the a to the end and multiply by c, which gives us the basic trinomial. You see the strategy. This is going to give us an easy one. X squared plus 4x minus 60. Now, one of two things is going to happen, right? And all we did was we just slipped the 15 to the end and multiply, right? That's the first step of slip and slide. Okay, what's going to happen here? One of two things. Either I can find magic numbers and I can keep going, or I can't, and I cross this out, and that's prime. Okay, step 2 is just factor it. Factor this basic trinomial. Can I find magic numbers that work? Multiply to negative 60 and add to 4. and positive 10, negative 6. Okay, good. So we factored it, okay? And we're not done. Okay, now step 3. What comes next? There you go. We take our magic numbers and we're going to divide each of those by the number that we slipped. So we divide the 10 by 15 and the 6 by 15. And then what do we do for step 4? Good. Reduce fractions. Okay, so then this is going to become x plus, what is 10/15 reduced to? 2/3. And 6/15 reduces to 3 and, oh, hold on, are you sure? 2/5. I can divide them each by 3, okay? And then the very last step. Ah, there we go. Good. The last step is to slide. So the very last thing we do is we take the denominators and we slide them up in front of the x's. Now they don't go in front of the parentheses, they just go in front of the x's. Like that. And so now that gives us our final answer, which is just, when I slide the 3 up, I'm going to get a 3x plus 2. I slide the 5 up, and I get a 5x minus 2, and I'm done. That's it. Okay? Okay? Good? Give me thumbs. Are we okay on that? Okay? You might want to practice a couple of those for the test. Okay, this is the easiest problem on the test by far. The factoring's already done for you. What do you do here? Yeah. Yep. So what is it? -9 and 1. Yeah. Okay. Super easy because look, all we have to do here is apply the zero product property. I've got a product of factors that's equal to 0, right? So what's that tell us? Remember the zero product property we talked about? Zero product property just says that if I have A times B is equal to 0, what's that tell me? Yeah, either A equals 0 or B equals 0, right? So if I have a product of factors equal to 0, then all I have to do is just find the values of x that make each factor 0. In other words, we're finding the zeros of the factors. So what's the value of x that's going to make the first factor 0? 1. So there's one solution, x equals 1. I know it works because if I plug it in, look what happens. 1 minus 1 is 0 times, who cares? 0 times anything is 0, right? What's my other solution? Yeah, the other solution, x equals -9, because what plus 9 is 0? -9. I can prove it. Plug -9 in. -9 minus 1 is -10 times 0 is 0. It worked. Okay? Easy. Easiest problem on the test. Okay, give me thumbs. We good? So that's just there. Strategically, I just put that one there to kind of get you in zero product property mode. So you're kind of thinking about setting factors equal to 0 when everything is equal to 0. Okay, how about this one? What do I have to do here? Yeah, good. I've got to get it equal to 0, right? Right now it's not equal to 0. My goal is if I can get it all equal to 0, then I can do that trick I just did, right? The zero product property, if I can factor it. Okay, so step 1, we're going to push those terms over to the other side so we get this whole thing equal to 0. So that gives me x squared, and I want the biggest power of x to always be positive, right? So my x squared is positive, minus 5x minus 14 equals 0, right? Okay, now I've got on the left side, I've got a trinomial. So my job is just, can I factor that into a product of factors? There you go. So those are my magic numbers. They have to multiply to -14 and add to -5, so that's a -7 and a +2. So what's that give me for my solutions then? There you go. So either x equals 7 or x equals -2, right? Because the only way I can multiply and get 0 is if I either make that factor 0 or that factor 0. And those are the values of x that make those two things happen. How do I find them? Just ask yourself, what minus 7 is 0? Well, 7, right? What plus 2 is 0? -2. Okay, thumbs? Okay. Okay, this one I got to fix. We need an x here. That's right. Your teacher, you can do those things. No rules apply. So what am I going to do here first? Yeah, I got to get it equal to 0. Good. So let's move everything to the side. I want a positive number of x cubed because that's my biggest power of x. So move everything to the left side. And that's going to give me 3x cubed minus 15x squared minus 42x equals 0. And that's the point. It's got to equal 0. Okay, now the left side. We've got to find, Caleb, put that phone away, please. So we need to factor that, right? Good. Always we want to see if we can undistribute something. Good. So first step is, can we undistribute a GCF? Yeah, we can. We can undistribute a 3 and an x. And if we do that, what's left behind? Well, we could just divide each term by 3x to see what's left. So 3x cubed divided by 3x is x squared. In other words, 3x times what is 3x cubed? Well, x squared. Negative 15x squared divided by 3x. Okay. And then minus 42x divided by minus 3. Okay, there we go. Okay, good. So that helps. Now we got a 3x out front. That's one factor that's done. But I've got a trinomial here. What do you think? Yep, good. Okay, can I break apart that trinomial? Are there magic numbers that would work? Negative 7 and 2. Okay, so we can split this thing apart into x minus 7 and x plus 2. Now don't forget I've got my 3x out front still. Equals 0. Now all I've got to do here is just, now I've got it broken apart into a product of 3 factors. The product can only equal 0 when the factors are 0. So I just have to find for each of those factors that has a variable in it. And they all have a variable, don't they? 3x has a variable, x minus 7 has a variable, x plus 2 has an x also. I got to figure out what are the values of x that would make that factor 0. Okay, the first one is actually the easiest one, even though it may not seem that way at first. 3 times what is 0? 0. There you go. So the first solution is x equals 0, or x equals 7, or x equals negative 2. So my 3 solutions are 0, 7, and negative 2. Okay? Thumbs. Okay, good. Okay, so now we're moving on to just simplifying radical stuff. Okay? So simplifying radicals. All we got to do here, I've got a 2 outside of the radical already. Now I just have to see if I can get a couple to go out in front with the 2. Right? So this is a factor tree kind of a thing. Start with our 125. I'll look when we're done. I think it's like 22, something like that maybe. 20, 22, something like that. So is there a perfect square factor of 125? Okay, 25 and 5, right? We always want to put the perfect square on the left. So there's my 25, there's my 5. What does the 25 break down into? Why did we pick a perfect square? 5 and 5. So I got a couple of 5s, and I've got a single 5 left over. Okay, so then what am I going to get for my answer? Well, I've already got the 2 out front. Now I just have to know, what do I get from my simplifying my square root? What's my outside number? 5, because of this, right? That gives me a 5. And then my inside number? 5. From this 5. And so my final answer then, I can simplify that. I've got some outside numbers here being multiplied. What does that give me? 2 times 5 is 10. So I get 10 outside and 5 inside. Done. Thumbs? Okay. All right. No tents in the basement. We always want to try to simplify the square roots, but I'm stuck. There's nothing I can do with those square roots. Okay, but I can't leave the 10 in the basement. So how do I remedy that? What am I multiplying top and bottom by? Square root of 7. There we go. Okay, what's that give me? Now on the bottom, I'm multiplying two inside numbers. Square root of 7 times square root of 7 is square root of 49, which is 7. And we knew that because anytime we multiply a square root by itself, it just ends up undoing the radical, right? So on the bottom, I'm getting a 7. On the top, what do I get? Square root of 35. They're both inside numbers, so I'm multiplying them inside the square root, and I get the square root of 35, which I cannot simplify. There are no couples contained in 35, right? Okay, I'm done. Thumbs? Okay. All right, solve. Solve.
We would like to invite any students interested in trucks to Hubble telescope engineering careers to the auditorium. If you haven't already registered, you can do so when you get to the auditorium. Thank you.
Anybody want to see that one about engineering? Okay. Okay, so this is different than the first when we were solving equations earlier, right? We did some stuff like, let's go back, like this. Solve the equation. So we were unable to combine like terms here. I've got different powers of x, and so I can't combine them. And so even after I set it equal to 0, there's no way I can ever isolate an x, a single x, because I have multiple x's up there. So this is the kind we have to factor and use the zero product property on, right? We can't just isolate x. This is an easier problem, I would say, because we can point to a single x. And what's the rule? If I can point to a single x, I can isolate it using inverse operations. Okay, now remember, when we're isolating, when we're doing inverse operations, the whole point is every step should allow me to cancel something off the left side and eventually just get the x by itself. So what's my first step going to be here? I'm going to square root, good, because there's no addition or subtraction or multiplication or division outside of parentheses, right? So the very first thing I run into here is I've got this square root that I've got to undo. Well, how do it's got a squared an exponent. I have a squared I have to undo, and I undo that by square rooting, right? And the whole point here is that's great because now I get to cancel something. Canceled my exponent, which gets me closer to getting that x by itself. Okay, there's a trick here, though. There's one tricky part of this. It seems pretty simple, but what do I have to remember to include? Good, the plus or minus. Okay, that's the part that people are, if you miss anything, that's probably what you'll miss. Now what? From here on out, it looks pretty simple. What's my next step to isolate the x? Okay, where do I put the 1? In front of the plus or minus. Good. So we've got, I'm going to add 1 to both sides, and the 1's going in front, and that's good because, again, I get to cancel something. So now I've got my 5x equals 1 plus or minus the square root of 26. So look, that's 2 for 1 deal, right? I get 1 answer for the plus, 1 for the minus. Last step, divide by 5, and we're done. And again, the whole point of that is so I can cancel something. And now the x is by itself, and there are my 2 solutions. So if I want to write these in the answer box on the test, it's going to say separate your answers with a comma. So what am I going to write? All divided by, so the division bar goes over or goes under everything, right? Divided by the common denominator 5. Comma 1 minus square root of 26, all divided by 5. Okay, good? Thumbs? Okay, oh man, this is good.